All right, cool. Well, let's dive in here a little bit. And hey, Juan. So I am going to share my screen. As soon as I figure out which window I want. I think it's this one. Okay. Yep. Let's see. And maybe we'll see if that size works. We get away with a slightly smaller size. All right. So to refresh on where we are kind of knee deep in our little ZIO actors project, which is not the real ZIO actors, but we're kind of making our own ZIO actors. So just note that here that when we do this, we're like importing R1 and not the actual library for educational and learning and fun purposes. But it's probably a similar interface, but not exactly the same interface. And we had, I think, done decent work to have the concept of a local actor here. And so basically we had this actor system, and you could create this actor system with this actor system.make. And then once you had one of these actor systems, it let you actually make an actor. And we're here defining an actor as basically this like stateful function or this state machine that starts off with some initial state. And then this essentially is the behavior of the actor. Maybe if we wanted to, we could even extract this out into its own type and call this like behavior or something. But basically we're saying a behavior is something that takes the original state of the actor, takes a message coming in, and maybe using this environment, gives us back a new state and a response. And then once we have one of these actors, or actually not the actor itself, but this actor ref, then we can do our usual actor type things on it of basically we can send it messages, which is kind of fire and forget, or we can ask it and we send it a message and then it'll give us back a response and we'll asynchronously wait for that. And then we had our little example here where we had a temperature actor. So this accepts these temperature messages that basically either say set the temperature to this value or get the temperature. And then we had a pretty nice implementation here where just for arbitrary reasons, we're starting with the temperature being at 0. And then we can set it, and then we just set the value and we return unit, or we can get it, and then we leave the value unchanged and we just return it. And so we had this little example here just to see how all this feels like. We make our actor system. We use that to make this temperature actor. We tell it to set the temperature. We ask it what the temperature is, and we print it out. And I get my SBT going here. And I haven't project actors run. And we get the temperature we set. So not amazingly exciting, but I think this like feels pretty nice in terms of at least an API here. And then we also spent some time last time looking a little bit about different definitions of what it might mean to shut down the actor. And originally we had one that we used fork scoped here. And so basically shutting down the actor meant just interrupting this fiber that was the one that was processing all these messages. We talked about having some desire for kind of a graceful shutdown concept. Right now, we're doing this queue with finalizer shutdown. So what it means to shut down the actor is to shut down the queue, which means that the next time you try to take an element to it or offer one, you'll get interrupted. I think there are some other concepts we could explore. I think another one might be you could imagine that these messages, maybe in addition to being able to take user messages, an actor can also take some types of protocol level messages. So you could have like a poison pill type message. And then maybe what it means to shut down the actor is to basically like offer the poison pill to the actor. And then when it processes it, it stops processing there. I feel like some of these like terms for these things are like kind of morbid, right? Like we're going to send the poison pill to this poor actor. But I think that's another way we could do it. But I think right now for today, I want to just kind of note that. And I mean, maybe we can come back that another time, but not spend too much more time on kind of different definitions of shutting down and try to work on building other stuff. So let me just check in on there's any questions here. Okay, perfect. So let's then talk a little bit about plan for today. So I think our overall goal for our next step was we wanted to support some notion of distributed actors. And definitely, like, we're not going to get into everything in distributed computing. Like, I think, or maybe we'll do another set of things where we like do some kind of distributed consensus. But right now, I'm kind of going to try to do a very, very simple one. But I think the goal, if we try to kind of have a goal for ourselves, would be, let's say we can send a message to an actor ref from an actor system in one process, and have that message get executed by an actor that is running on an actor system in another process. And do this in a way where I'll say we can convince ourselves that if those processes were on different machines, this would work. I think we'll just do it on my machine. But in other words, we're not going to do something like, well, we're just going to like write something to like a local file or something. So the idea would be basically when we're done with this, which I think may not be today, I think we'll may just kind of work through the stuff for this today and may take another session for this. But basically, by the time we're done with this, I'd be able to go down here. I'd be able to basically spin up a second one of these, and we would essentially be able to, in one of these, run something that maybe starts like a temperature actor, and then in the other one, I have a program that sends a message and references the temperature actor on the first process, and then we actually get kind of the same results we had down here. So I think that's what I'm going to try to do. Definitely, if you have comments on if that makes sense or not, now's the time for them, because otherwise we're going to start working on this. And let's talk a little bit about how we're going to do this. I think, again, there are definitely different approaches that we can take, but here's what I'm thinking right now. I think we introduced concept of I think what we'll call maybe an actor ID. And the actor ID is basically two things. So one of them is going to be, we can pick words, right? Words are a hard thing, but one is going to be location. And so this would basically be like a host and port of the actor system where this actor is physically located, we'll say, even though physical or digital located is the right terminology. And then the second part is an actual ID, which is basically kind of a unique identifier within a we'll call it like a physical instantiation of an actor system. And so the idea would be those two together. Oops. Are going to uniquely identify an actor, right? So you can imagine we have something like, I mean, in our simple example, it's going to be like localhost 8080, and then maybe the first one's going to be 1, and then we'll have localhost 8080 and 2, and we might have maybe our other one is going to run on a different port, and this is going to be 8081, and this can also be 1, and that's fine because it's the combination of these that uniquely identifies one of these actor IDs. So then I think our concept would be that each time we start an actor system in a process, we also start a server that corresponds to that actor system. And then when we send a message to an actor ref associated with an actor system, we do the following. So first we check whether the location of the actor is on our, I'll call it machine, even though they may actually kind of run on all, they're all going to run on my machine, but they'll run on different processes. If so, run it as before. If not, then forward the request to the server that responds to that actor system and either wait or not, depending on if it is a ask or tell. How does that sound to everyone as a plan here? You're being a little bit of a quiet bunch today, which is fine, but I'm gonna start doing things, so I figure we should like at least align on it before we start doing it. Okay, cool. All right, so I got at least one thumbs up, and I think along the way we're definitely going to run into some issues of like we're basically going to need to well, we're going to need to serialize these messages, and we're also need some protocol for doing this. So I think that'll be kind of some fun opportunities to bring in some other ZIO libraries. And so maybe to elaborate on that a little more. And yeah, I think Nathan's kind of going the direction I'm going. So I think one choice we have is just basically what communication protocol we're going to have. And I think the main options would be kind of a like REST type ZIO HTTP one or like a gRPC one. I think I'm going to say like hypothesis is use ZIO HTTP. I think partly just I think that'll be kind of a fun thing for us to like learn and play with, and we'll get to use like endpoints and stuff like that. And then yeah, I think we're going to say we'll need to deal with serialization and the serialization of messages. We'll probably okay. Cool. So I think this gives us a reasonable plan to start to work on here. And I think what I'm going to do for most of this, because this is all basically everything we're going to do here, almost everything is going to really be internal. I think if we go back to like our example here, obviously to at least do the remote example, we're going to actually have two different processes that have some of this stuff. But beyond that, I don't think there's going to be a whole lot that's going to change in the user-facing API other than maybe this actor system.make is going to take some type of configuration that basically says like, what is the like toasted port that you should use for the server. So almost all of the code we're going to write here, which I think is going to be a decent amount, is really just going to be like internal to really the implementation of this actor system. And so I think what I'll do is I'll create a new internal package here that will kind of wrap up a lot of these concepts here. So let's try to start working through this. So I think the first thing we said is we want this concept of an actor ID, and this has some other stuff. And I almost feel like this has like needs to have some other name associated with it, but let's just kind of try playing with this. So I'll create a new file. It's called actor ID.scala. And then I'll do one called location ID. And maybe I'll call that other one something like local ID. We can decide if we like these names. And so let's start basically very basic. So this will be, I guess, active ZIO, actors internal. And so I think a location is basically going to be like, I mean, at least that's like the simplest possible way we could do it. And then let's say local ID, yeah, maybe just be a long. And then so this then just needs a location and a local ID. Okay. So then I think the most basic thing we can do here is we're going to have to start flowing a little bit of these concepts into our actor system here, because it's going to need to have some concept of what is that host and port. So maybe something we would want to do here, if we wanted to, this could potentially, maybe we have something down here, like we have a like class actor system config, and maybe that has the host and the port, and then maybe we can have a couple of variants here. So maybe this one is kind of going to be our most general one. So this will take a scope and a config now. And then maybe we can have another variant. Let's see. Make. And this one won't require the config at all, but maybe this will let you explicitly pass it. It's kind of deaf. This is one pattern I kind of like. I see some people who just provide this, and that can get a little bit annoying for users when they want to compose everything as part of layers, because then this doesn't really nicely fit together. But of course, sometimes people want this because they don't want to create a bunch of other layers. They just want to like do this thing. So I think it's kind of nice sometimes to have like both of these variants. We could maybe play with the names here of like maybe one is like configured or something. But I think maybe right now I'm okay with just overloading the name and just having this variant. And then this can be pretty simple here. Let's see. I can just do make, and then I can provide some, I can just do with provide some environment, scope, and then I can just do some environment, big host. Let's see if I got that right. Oh, I called it actor system config. I think I will just call it config here because we're already in this actor system namespace, but that would definitely not make sense as is. And then, right, this needs to be config. And I can just do the simplest version. We do the later, but I'm just let's just do the Okay, there we go. And now this thing, our one change is we're going to now need to say something about this. So now we say, hey, start this actor system up at this location. So now we've got our example working again. And now we're going to want to go here and we're going to want to actually use this information here. So the first thing that we can maybe do is we can say config in ZIO.service config. So this will actually give us access to this config. So we're now able to know the host and the port where we are supposed to be running. And so we're definitely going to need to do some stuff to like actually start a server here, but we'll defer that because we need to actually like implement a bunch of stuff for that. But I think the most basic thing here is let's look at what's going on with making this actor ref here. So what we were doing before is we made the actor and then we created this ID thing and we put it in the map here. But right now we were just directly, anytime you called with this actor ref, you were just directly sending a message here. And that's fine for, like right now, all the ones we're creating here are the ones that are local to us. So what we may need to play with this a little bit is maybe we need the concept of the ability to make an actor ref that is not necessarily associated with us. So maybe we need something here. Right now I'm going to call this, let's see, I'm thinking about the best API for this. So yeah, maybe we need something like unsafe make. And so I think this is not really going to have any concept of an environment or a state. It's just going to have a message and a response. And this one is going to need a actor ID. Then it's going to give us an actor ref here. And then we're going to need to kernel stuff. Okay. And so let's think about what this is saying. So this is saying, I've somehow got hold of this basically reference of I know where this actor is that exists, maybe not on this machine anymore, maybe anywhere. And I want to create a reference that lets me send messages and interact with it. So I think this is something that right now is going to be probably part of our internal API. Maybe we'll eventually want to make this private. And we'll have some higher level tools that let you kind of get these references. Like probably one thing eventually this make method needs to have, it needs to have some other like context thing that essentially has the sender or maybe we'll embed that as part of the messages of like when you send a message, you can send back your actor ID. I think we can play with that a little bit, but right now I just want to get some of this like machinery working for us. So I think something like this is basically what we want to implement. Maybe I'll make this private actors for now. Spell things correctly. And this we're not going to be able to define here. So we're going to need to be able to define down here. Grab that. Okay, so what would it mean to create this actor ref for this based on this actor ID? Well, so I think we could say something like, let me start by just using ZIO.succeed here, see if we need some kind of ZIO workflows here. So we're definitely going to want a new actor ref that accepts this message type. And then the actor ref has these two methods that we got to implement. So let's grab those. Oops. Okay. So what would it mean to send a message to this actor? Well, I think what we could do here is first, we want to know, is this actor ID one that is at our location or at another location? So maybe we say something here like, we could say if actor ID dot location is equal to our location, then we're going to do one thing. Otherwise, we're going to do something else. Let me just check in on our chat here. Okay, good. So Nathan, is this for addressing the remote distributed potential nature of actors? Yeah, so I mean, I think everything we're doing is basically, we want this to be remote. I think just the fact that I only have one computer here and I don't want to set up too much infrastructure to demo this is like, the remote is basically going to be, it's just going to be like two different processes on my own computer running on 8080 and 8081 or something. But yes, I think conceptually we will kind of do everything as if it's that 8081 is not just another process running right below it. Okay, so basically if it's at our location, we're going to do one thing. If it's not, we're going to do something else. And I think we can probably do the same thing down here, and maybe we can further abstract this, but right now I'm definitely just going to kind of do it. Okay, so if it's at our location, then I think it's hopefully relatively easy with what we had before here, because we have this map. And now I think we see that this map probably needs to change slightly. So I think this long is basically this local ID type we had that is just a long, but slightly more stronger typed. So I'm going to change that to local ID. Then I think I need to change that to local ID so this still compiles. Let me make sure that's still working. Location is not a member. Oh, okay. Yeah, so let's do location is equal to location of the host and the port. So basically just extract that out. And then I can say, if the actor's location is our location, do one thing, otherwise do something else. Okay, so if the actor's location is our location, then we should be able to do actors dot get actor ID dot local ID. And then we could match on that. And so we basically have two possibilities, right? That we either got an actor or we got none. Just make sure this is. I see. Okay. Okay. So remember, when you remember that this is a ref, not an actual map itself. So we got to get that first. So let's just add one more. So actors dot get dot flat map. Oops. And just pull that there. Okay. So if there's an actor there, then our life is really simple, right? Because then we just send the message to the actor. I think, let's see. And I think we may need some casting here. Let's see. So yes. So I think we basically the problem we're running into is just that we have a specific actor here, but our map is basically a map of all these actors that accept unknown message types. So I think we can just do actor dot as instance of actor any. Let's see if that will make this happen. I feel like maybe we haven't solved quite this problem elsewhere. Let's see. What we just did. Just name this instance of actor message. There we go. Okay. So this is the easy case. Now this case is kind of where the like unsafe comes in, because basically we should be enforcing at a higher level that you can never get an actor ID for an actor that you can never get an invalid actor ID. So I think here it's fine to just do something like we could just do like ZIO that die message. Yeah, I think that's probably fine. Okay. And then this other branch, so this is the remote branch. And this one we're gonna punt on for now, because we're gonna I mean, we can kind of say conceptually this is where we would like use a client and call this server, and we now know from this actor ID dot location what server we need to call, and we would call it and do all that, but we've got to actually set that up. So we're going to leave that as a question mark for now. And then I think I can basically just kind of grab this and bring this down here. And here, all I need to do is I just need to change that to tell. And then I think I'll be all set here. Yeah, you're exactly right, Nate. It's a little bit like what I was doing with the poison pill. So let's see. Tell actor as actor. Oh, let me make sure I have these right. Oh, ask. I did send and ask. We don't have tell is not actually a thing we have. Okay. All right. So now we've got all of this working. And if we wanted to, we could probably do a simple example for ourselves where we like create an unsafe reference to this thing and send it something. But I think we can kind of see that like this is going to do what we want it for in the local case. So let's start to think about the remote case. So basically what we're going to do here is we're going to create a client here that's going to call the server that's associated with the actor where this thing is actually running, and we're going to like call that server. So I think if we're going to use ZIO HTTP, our first step there is probably to define some endpoints that are essentially going to represent this server that's associated with each of these actor systems. And then once we've done that, we can use that to actually create a server. And essentially in this make thing up here, when we initially create, or sorry, this make thing up here, when we're creating this actor system, we'll also spin up the server, and we can tie the life of the server also to this scope here. So I think this will be a good opportunity for us to all learn some of the latest ZIO HTTP together. But I think I'm going to start off by creating this, what I think I'll call here is endpoints. So it's the ZIO.actors.internal. And so this is just going to house my different endpoints. And so endpoints in ZIO HTTP are like a declarative description of just basically what an endpoint is separate from its implementation. So to do this, I'm going to need to actually bring in ZIO HTTP first. So let me go down here and add that to my build file. And give me 1 sec. I'm just going to actually go over to ZIO HTTP GitHub and grab the dependency I got to add. So on 300 RC3. So we'll reload, we'll bring that in. Okay, and so here then I can do import ZIO.http its endpoint all. Make sure that's actually a valid thing. Okay, and so I think probably we're going to want 2 endpoints that basically correspond to these 2 things. So you could imagine we'll have like a send endpoint and an ask endpoint. Maybe eventually we'll have like other endpoints that say like, well, tell me all the actors you're responsible for or something like that. But I think right now those are like the 2 that it seems we need. So let's try doing one of these. So we could say val send. And then the way we make one of these endpoints, if I'm remembering correctly, is we basically do endpoint apply. And then I think I also want just normal ZIO HTTP imported here. And then I basically do method first. So this maybe probably should be a post versus a get. And then we just need to think of like what our thing is. And I think maybe it should, I'm just like, I don't know, trying to come up with a nice like RESTful API and stuff. So maybe it should be like actors. And then we already know by the time we're sending it to this, we know the location. So we just need the basically the local ID. So maybe at this point we can call this the ID. And so that could be like a long, we could give ID. And then maybe we call that send. I think that should, let's see. Oh, I think maybe it's lowercase. Let's see. Yep. And so I think this is where I wish my VS Code was helping me out, but it's not. So let me just grab this. Not that this is like the prettiest type signature here, but Why is this not? Oh, right, just because I said it was one thing, it's clearly not that thing. So let's look at this and let's just see what it is for a second. If this is correct. Oh, I did need that middleware thing. Yep. Okay. And if we click through to this, okay, that's annoying. That's not the correct endpoint. I want this is supposed to be the ZIO HTTP endpoint. Let's see, is this the, no, that's not the right endpoint either. Okay, give me a sec here. I'm just going to pull up ZIO HTTP so we can look at this together. So as part of our little joint learning here. So if I go to endpoint, yeah, so Nabil says he doesn't explicitly type it and let's infer, and maybe that's what we should do. So maybe I'll take a page from him here. I think it's good we have Nabil here because he works very closely with ZIO HTTP, so he'll kind of correct me as I go here. But we can see at this endpoint, basically, it has these different types that represent the path input, the error can fail with, the output, and then any middleware that's being used there. So I think that's probably a good suggestion to not do the type things. Let's see, I got to figure out how to actually get back to my original one. So yeah, maybe let's get rid of this. And then I think I want to add a couple things to this. So right now, this is like the actual path, basically. But it doesn't say any inputs that are expected as part of like the body. And it also doesn't say what this returns. But we can add that pretty easily of like, let's just do this kind of illustratively. So I can basically do like in int dot out string. Get this going again. Nabil is a very awesome human. Actors, compile. Okay, and now if I just do my little trick to show the type signature again, we'll see. All right, well, this maybe with all this. Okay. We can see now that I'm getting back my string. Yeah, okay, this is not the most helpful. So I think I'll stick with not having the type annotations here. But basically, this is saying, okay, this accepts an input that's an int, and it's going to give me an output that's a string. So I think this first part actually seems decent for what we want. The second part is definitely not what we want yet. So this send endpoint, if we go back to the send actually doesn't need to return anything. So I think for the send endpoint, we are okay not having an out value here, or I think we could do out unit. I'm not sure if Nabil can tell me if that's like necessary or like valuable at all, but I'll take that out for now. But we are going to need some in type that basically is going to need to represent the message, because we need to send this message. And I think this is where there's a little bit of interesting thinking we need to do, because this endpoint needs to basically be able to handle any message type, even though it doesn't know what that message type is. So in some cases, like the message type is going to be, if we go to our example, is going to be the temperature message. But in another case, it could be, I don't know, like a counter message or a user message, or basically any of an infinite number of messages. And so normally when we would do these endpoints, we would have like a specific thing, and we would say, okay, well, this accepts an in of like a user request or whatever. But here, I think we do want some type of maybe we'll call this like a actor request. And so this will basically accept one of these actor requests, but we need to, okay, oh, good. So we're getting the, yeah, the compiler is pushing us here on exactly kind of where we need to go here. So if we look at the compilation error we're getting here, basically when we accept one of these input types, ZIO HTTP is going to require a schema for that so that it knows how to encode and decode those things. And we can start to do that ourselves. So let's start with kind of the simplest possible actor request. So let's just to get this compiling again, let's say this was a case object actor request. And then this is going to need to be actor request.type to compile. And then or maybe I'll just give it, maybe just so I don't have to do that, I'll give it a, I'll just put like an int inside. So my final case class actor request. And I don't know, I'll give it like an ID that's so if I have that, and then I have this thing here. So it says it needs a schema, and a schema basically describes the structure of data. It's from this library called ZIO schema. That's like one of the I think unsung heroes of the ZIO ecosystem. And it's this concept of kind of the structure of data is really useful. I mean, one, it lets you describe how to serialize and deserialize something in different ways. So like if I have a schema for this thing, I could encode it as JSON, or I could encode it as protobuf, or I can encode it as Avro. I could do whatever I wanted with it. And I can also do a lot of other fancy stuff with it of like, I could like migrate it to like an actor request v2 that had some other field in addition to this. But I think for our purposes, we're basically just going to be using that like encoding, decoding functionality. So what I can do is I can create a companion object for my actor request. And then I can do like implicit val schema is equal to, and I'll import zio.schema.all, which I believe I'll have because of ZIO HTTP uses it. And I can just say derive schema.generate this schema. So I think that should, let's see, what have I got going on here? Oh, okay. This is one case where I think because I'm on scale 3, I need to actually give this type, which in this case is easy because it's not some super big scary type. It's just a schema of an actor request. And now everything is happy here. So basically, because ZIO HTTP has the schema, it knows how to serialize and deserialize these actor requests. So this is now, I think, nice, other than the fact that this actor request clearly can't just be an ID. It's got to have like the actual information in there from all these different arbitrary message types. So let's come back to that in 1 second. Let's just do the other endpoint as well. So basically, I think we were calling them send and ask. Okay. So ask can be, I think, very similar, with I think the only new thing being that this is now actually going to have to give us some response value beyond just like okay, because if we go back to the signature of the ask, it actually needs to give us back, like if we go back to the temperature message example, it needs to actually give us back the temperature. So this one then, I think, is going to, need to have some type of actor response. And we can basically do the same thing here. So, this response. So now we've got all this working, and we've kind of got descriptions of these endpoints. So one thing we've got to do is we've got to actually implement these endpoints, and we got to create a client and a server based on them. But the other thing I think we need to do before that is we need to at least make some progress on figuring out what these actor requests and actor responses are going to be. And so the challenge, I think, basically is at the level of like these like actors. When we make an actor, let me go to the actor system where we do it. So here we can pretty easily just basically by just doing this, we can require that when you create an actor that there be a schema for your message type. And it'll be easy for the user to create those schema because they can just do that derived gen thing, which is basically going to work as long as you have like a case class or like a seal trait hierarchy that is from things that themselves can have schemas derived for. So every individual message type is going to have its own schema. But when we've got our server here, our server essentially has to support every different schema possible, right? Because we may have, again, this like temperature messages coming in and these other things coming in. And so what I think probably makes sense is to essentially solve this problem at a different level of, say, at the level of this actor request, this message, the contents of this are already going to be serialized. And it's really going to be the responsibility of us in this unsafe make here. We can require a schema for this message. So we'll serialize it here ourselves. And then when we actually create this actor for the first time, we'll create the schema here, and we can even store it with the actor if we want to. And so basically both of these two remote servers are going to have the schemas to serialize and deserialize it. And we're going to handle that at this level of our protocol. And our actor request and actor response are basically going to just be the contents as essentially a chunk of bytes. So I think that's the way I'm going to suggest we approach this. So let's make this maybe chunk bytes. And this is these are like known data structures. So we can still, we can do it as long as I actually do the import that has a data type. And similarly, this response, I think, can have a value that's a chunk bytes here. Okay. So now we've got our endpoints defined, and I think we're at least relatively clear on what these are. So now let's think a little bit about so we basically need like a client and a server side of this. So I think probably we want to think about the server first. So why don't I create another file here? Maybe I'll call this actorserver.scala. And so the next basically step is that now that we've got our endpoints here, remember this basically says what this interface is, but it doesn't say how it's going to be implemented. And so the next step is we could actually go and implement each of these. And that would take this from being just an endpoint to being a route and a handler. And then we can combine these two together to get basically the full logic for our server. So let's start on that. And I think we'll probably break kind of midway through that just because we're kind of coming up on the hour here. But so let's try doing one of these. So the first one we said was send. So maybe here, val send is going to be endpoints dot send dot implement. And let me see if I can just show you this first. So I think we got to give the types here. So when we implement the send, we basically get a function from these different parameters we took in here. So I believe this one should be giving us two parameters. That's basically the ID and the actor request. So let's see if this is here. Let's see. If I go to one of these ZIO HTTP examples, and let's just see if I'm doing something. This thing like here. I see. Oh, I see. I needed the handler. Right. I implement with a handler. So that was my bad. Okay. So let me go back. It's making up something. Okay. So I can implement this with, I think this will be a long and an actor request. And then this will be ID. It's a long request. Actor request. And then maybe right now we'll just do ZIO.unit because we keep it. I think that, and then let me bring in ZIO.unit. Okay. And I see. So I do want to do, so if I go back to my endpoint here, I do want this to just be out unit. Just want to specify that. And then this is happy. Okay, great. So what I'm saying now is I've got this endpoint, and now here's how I'm going to actually implement it. Here is the handler that is going to handle everything that comes into this endpoint. And the handler is created right now. There are a lot of different constructors for handlers, but right now we're using this from function ZIO1. And so it's going to get access to two things, this the ID and the actor request. And then it gets to construct some type of response here. So I think this is definitely going in the right direction here. Basically, what we're going to want to do from here is we're going to want to, this thing needs a little bit more information. It basically is going to need some of the information from the actor system that originally created it, because basically the way it's going to fulfill this request is it's going to have access to this actors ref, and it's going to use that to, sorry, I'm bouncing between these different ones here. It's going to use that to actually fulfill this. So I think we can just do this with as part of the ZIO environment here. That's probably a nice way to do this. And then we'll just do the same thing for this, as well as for the other endpoint. So we can similarly do ask endpoints.ask. And then this, right now I'll just say ZIO message. Is this one I need to actually return a response, which I don't have an ability to do yet. So I think this is probably a good stopping point for today. Next time we'll keep working on our implementation of this, and so we'll basically implement these two functions, and then we can create a server from them, and we can create a client, and I think then we'll basically be good to go here. We'll have to do a little bit with the encoding and decoding, just making sure we're keeping track of the schemas in the right place. But hopefully this has been helpful to kind of see how we're approaching this and get some of the logic in place for this. Let me just check in on the chat, and then we'll call it a day here. All right. Well, yeah, please jump in if you have any questions, or otherwise I'll push up the code from this and we can keep working on this next time. But hope everyone is enjoying this series. I think it's been fun to kind of work on a little bit of a bigger thing than we sometimes do. So that's cool. All right, everyone. Well, yeah, I see a couple people are typing, so I'll just wait one sec. But otherwise, have a great weekend, everyone. All right, cool. Well, take care, and yeah, I'll push up the code. Bye.